This is section 1.3 day 1, and we are going to start just kind of a few days talking about different parts of graphs of functions. So this first day is just going to talk about domain and range, and then we're going to move into some calculator work. So it's going to be a couple days of just working with different functions. So hopefully you remember from your Algebra 2 days that domain is just all the x values and range is all the y values, which seems really simple when I can just pick out the numbers. Here's a set of points for a function, so my domain is just going to be all the x values. And my range is then all the y values. So 0, 4, I've got a 2. And then I do have another 2, I don't need to list it again, and then -1. So really easy to do domain and range when they're just listed for you. I can just make a list, no problem. Number 2, we're talking about the volume of a sphere as an equation, and I'm still asking you to do domain and range of that. So this is still the x values or the things I can plug in. These are still the y values or the things you get out. So although there's not an x in this equation, my variable is this r right here. So this is what I'm plugging things into. If I did not have the context of this being the volume of a sphere equation, I could plug in anything. I could plug in negatives and decimals and fractions and all kinds of things in there. But as soon as I decide that this is the volume of a sphere, it kind of restricts what I can plug in. Specifically, no negatives. It does not make sense for me to try and create a sphere that has a negative radius. So that doesn't make sense in the context of this problem. So my domain is just all the positive numbers. Now I can do decimals, I could do fractions, that kind of stuff, but I just cannot have negatives. And there's a few different ways you can write that. The easiest way, the shorthand way, is to say all real numbers but just the positive ones. You could also say as long as r is greater than 0, that would be my domain. Can't be equal to 0. Again, it doesn't make sense to have a negative radius or to have a radius of 0. Another way to write it is to say that it could be anything from 0 to infinity. And I'm using parentheses there because it means that I cannot use either 0 or infinity. 0 for obvious reasons, can't have a sphere with a radius of 0, but then infinity, you can't really get to infinity. So the parentheses are saying anywhere from 0 to infinity, just not including either of those. Your range then, if you think about it, no matter what positive value I plug in here and I square it, I am always going to get a positive volume for my sphere. So that means I could have the same notation there. My volume would be everything greater than 0, so I'm just going to do v is greater than 0. And this would also be the same. Anything bigger than 0 could go all the way to infinity. Next up, if I don't give you context to it and I just give you an equation, let's see if we can figure out what the domain and range will be. So I'm going to go ahead and graph this. If you have not used your graphing calculator yet, I'm going to show you a few things. Unfortunately, I am just working with a Texas Instrument, a TI-84. If you have a Casio, your best bet's going to be just to Google. It's not very difficult to do on yours. The keystrokes will just be different, so the buttons that you hit will be different. And I don't have a Casio here in order to show that, so all I've got is this TI, so that's what I'm going to stick with. So if you don't know how to graph in your TI, you're going to hit this y equals button, and then you have all of these different y equals that you could type in equations. You could effectively have 7 different functions going on your picture. We're just going to do one. It's going to be x squared minus 2. Your variable button is right here, so I'm going to hit that. In order to do a squared, you have 2 different options. You can either hit this button and then a 2, and that'll make it like to the power. You also have just a simple squared button, so you could hit that and you will just end up being squared. And then we have a minus 2. Make sure that you are using your actual subtraction button, not your negative. The only time you use this is when it's the first number. So if we had a negative x squared, then we'd use our negative button. But in this case, we are subtracting 2. And I don't know the last time you used your calculator or what your screen might be set to, so a great way to kind of make sure that everybody's looking at the same screen or the same setup is to hit zoom and then 6. It kind of puts everything back to kind of a standard window, kind of a 10 to 10 window, so that we're all looking at the same thing. And then there's my beautiful parabola and moved down 2. And we're going to do domain and range off of this. And I'm just going to give it a quick sketch on my picture so that I've got it for my notes. So this is a parabola and it was down 2, so I'm just going to go like that. And we're going to talk about the domain and range. So domain, again, is all of your x values. And one way I teach students to do that is to roll a pencil. And we're going to start from the left and we're going to roll it all the way to the right. And anytime I am touching the function, that is a piece or a member of my domain. Now we're not going to list them like this. My goodness, I'd be listing out every single possible number, including all the decimals between. We want to turn to kind of this type of notation, these options, in order to list our domain. So for this case, my arrows are going to go up and out forever. My domain is my x value, so I'm considering or I'm thinking about how far left to go. What would be the lowest left value that you could have, and that would be negative infinity, because that parabola is going to go up and out forever, which means all the way to the left. So I could write negative infinity. And then that whole pencil idea is just if I roll my pencil, I'm still hitting the function, I'm still touching the function, and how far can I go until I kind of run out of function? Well, on this side, I also have an arrow up and out, so that's going to go on forever, so that's going to be infinity. Another way that you could write it that we kind of talked about up above, instead of saying all the real numbers except just the positive ones, you could just say, I just want all the real numbers. There is not a number I could not plug in here. I can square negatives and positives and fractions and square roots and decimals, and there's nothing I can't square. Okay, so those are two things. You could also write, you could do negative infinity to x and then to infinity. So you could kind of sandwich x between negative infinity to infinity and saying I could be anything between them. This tends to be the one that students will use the most often. It's kind of the best shorthand that we have available to us. So that usually is the one kids use, but any one of those will be fine. Range then starts at the bottom. So range is y values, and you want to start as low as you can go and then go all the way to the top. So the lowest value we start with is actually -2. That's the lowest spot. And that's going to get a bracket because we actually are including -2. That's a filled in circle. That's a value I can have. It's an actual point on my graph. And as I roll my pencil up, it looks like I can keep touching the function. If I were to draw a horizontal line, I would touch the function. And it looks like those arrows are going to take me up and out forever, so that is to infinity. And a reminder that infinity gets a parenthesis because we can't include it. You could also write this as y is going to be greater than or equal to -2. So all the values greater than or equal to -2. Next up, we're going to graph this one. This is a rational function. We're going to do a lot with those in chapter 2. So 1 divided by, and then make sure anytime you have a fraction, you are protecting either the top or the bottom, but you protect it with parentheses so that you make sure that you're dividing by the whole thing and not just x. I'm going to hit zoom 6 again, just so I like that standard window so that we're looking at the same thing. And that is an interesting function. I bet just based off this, you can probably guess where these guys split off. And they split off at -5 because -5 plus 5 would be 0. Can't divide by 0, so that's a problem. Unfortunately, our graph only goes out to 4, so I'm just going to go out to 5 here. And what's really there is something called an asymptote, which you've talked about before in Algebra 2. It's like this dotted line, this imaginary line that we cannot cross. And I had one part of the graph looking like that, and I had another part of the graph looking like that. And you can pretty much tell just the way this is looking, like this is just coming and just hovering right along that axis. This guy's doing the same, just going out to the left and kind of hovering. So there's literally also an asymptote right here. Like they're not crossing that line. They're just getting really close to it, and much closer than I drew mine. Okay, so domain for this one. Again, we want to roll our pencil or start from the very left, and this arrow is going out there forever, so I definitely am starting at -infinity. And the problem is, as I roll my pencil in, I run into this asymptote, which there is no value here. So that asymptote is signifying that there's nothing here. It's almost like an invisible fence, and you can get really close to the invisible fence, but you can't cross it. So that happened at -5. We kind of talked about why that happened. So I have to stop at -5 and then start again at -5, which is kind of weird, but you're really just saying this half of the graph has to hop over -1/2 to hook up with that half. So you're kind of excluding -5. And then your pencil rolls all the way to infinity, so that will take care of it. You could also write, how would I want to write this? I could say all real numbers except x cannot be -5. Sorry, I'm getting really close to that one. So you could say everything except for, the only thing you got to leave out is this -5 because it's got that asymptote there. So it's just a different way to write it. Next up is range, so we'll start down low, as far low as we can go, and that arrow is going down forever, so that's a negative, and whoops, that's not even sideways. That's a negative infinity. And then rolling your pencil, you kind of run into that asymptote thing again. Like there's no value here, so this line is going to get super close, this one's going to get super close, but nobody's going to touch it. So, and that for a y value is actually at 0. So that kind of same phenomenon is happening when there's an asymptote. Or again, you could write all real numbers except this time y cannot be, and the value for that was 0. So remember, when you're talking about y's, make sure you're using a y value. When you talk about x's, make sure you talk about the x value. Next up, let's graph this. If you don't know how to graph a square root, clear. When you hit second and then your square root button, now on my calculator, it's going to keep extending that square root bar as I type. If yours doesn't do that, you're going to want to put parentheses to kind of protect everything that's supposed to be under there. So I'll type it that way even though my calculator is not doing it that way. So mine's going to be 4 minus 3x. See how mine kind of kept extending the root bar over all of that, so I wouldn't need the parentheses. But if yours doesn't do that, you want to make sure that you have that whole thing in parentheses, otherwise you're just going to get the square root of 4, which is not what you want. So I'm going to hit zoom 6, just like always. There you go, there's our function, looks really great. I'm going to give it a sketch. I'm not really sure where that's touching exactly, so it's hard to be specifics there, but I'll show you how to do that in a second. So I'm just going to kind of give it a picture just so I remember what it looked like. Domain is going to be all of my x values. So how far left can I start? That arrow is going all the way out and to the left. So that's negative infinity. And now we need to figure out where it's going to stop. One way to figure that out is to just take what's inside of here, 4 minus 3x, and you just set it greater than or equal to 0. You cannot take the square root of anything negative, so you can't do the square root of -1 or the square root of -2. So as long as all of that stuff stays greater than 0, it's going to stay positive, so I can square root it. So if I were to solve this, I would subtract the 4 over, and then I would divide by -3, remembering that when you divide, you have to switch the sign. So -4 over -3, you'd click that out, and you'd end up with 4/3. That's why it looks like it's a little bit over. That's why it looks like it's a little bit past that 1. It didn't hit exactly on that 1, it went past it. And that's why, because it's at 4/3, it's not really at 1. So that's going to go all the way up to 4/3. And we're going to include that because that is a number I could plug in here to make that equal 0. Another way to write it is you could say x is just going to be less than or equal to 4/3. That would be another way. Range on this one, we're going to start as low as possible, and that's hitting right at 0. So 0 is as low as we can go, and that's an included value. If I were to plug in 4/3, I would get 0, and the root of 0 is 0. So that's why 0 is included. It's a value we can have. And then range, we're just going to roll up, or how high will my graph go? And this arrow is going to go up and over forever, so that's going to be to an infinity. You could also do all the positives, or you could squeeze in a little y is greater than or equal to 0. Any one of those three will be just fine. 3 more examples to go. They're going to be very much like the ones we did up above. So the first one is just a 2 divided by x. This is going to look like another rational graph with an asymptote. This time our asymptote happens to be at 0. So I'm going to give that a sketch right here. We got an asymptote right there. I can see the other one is right there. And one half of my graph is in here, and the other half's right there. So domain is going to be everything except for that asymptote. So everything except for 0. So I'm going to write it 2 different ways. I could do negative infinity to 0 and then 0 to infinity. Or I could say all real numbers except x cannot be 0. Range, coincidentally, is going to be the exact same thing because its asymptote is also at 0. Arrows down and up in both directions. So I can take care of everything except for that 0 in the middle. Make sure that if you're going to use this notation, which kids do tend to prefer, that you make sure you're identifying the correct variable. Y goes with range, x goes with domain, and this is a not equal to. I can't have that value. It's the one thing I can't have. It's where an asymptote is. Next up, x squared plus 3. We know our x squareds are all parabolas, and this one's just going to be moved up 3 spots. So we'll give that one a sketch on our graph. Moved up 3. There it is. It's a pretty bad parabola, but you get the idea. Domain is what can I plug in there, or what are my x values. This goes up and out forever in both directions, so we are all real numbers or negative infinity to infinity. That would work. Your range, the lowest y value you have actually starts at 3, and that's an included value, and it goes to infinity. So that would work, or you could write y as everything greater than or equal to 3. Last one has another absolute value. And we've got 16 minus x squared. And that's an interesting graph, and it really does look like it's hovering right above there, like it's not connecting. And we're going to zoom in just a little bit so I can show you what's happening there. So I'm going to do a zoom, and number 2, which is in. And you can see the middle is starting to flash. That's because there's actually a cursor there. And just like on Google Maps, you can move it around and decide where you want to zoom in on, and that's where I want to zoom in. I want to get a better look at what's happening there. So now it went even closer. There's still a little bit of a gap, it looks like, but it went even closer. And I could keep zooming in and zooming in and zooming in. But your calculator is just having a hard time connecting those for you on this, well, on our particular calculator. I feel like, I forget which one of these calculators does it. The new ones, I think, with the color, I think they'll actually connect it for you so you won't see the gap. So what we're going to look at is kind of like what we did up above for that root, is we're going to look at the inside. What are some values that I couldn't have here? So 16 minus x squared, we got to keep that bigger than 0. And in order to do that, we would take the 16 over, divide by -1. Remember, that will flip our sign, so we'll have 16. And then I'll root both sides, so it looks like we are going to be less than or equal to 4. And when you square root it, you actually are going to also have the negative values, because I could do a -4 in there and I would still be okay with my 16. So we're going to be less than that, but we're going to be greater than -4. It's a little confusing, but that's why we graphed it as well, so we could kind of verify what we were doing with our visual. So we can kind of see that we're going, our domain is going all the way from -4 over to +4. So it looks something like this. Going from -4 to +4, and then if you count up, that hits at 4. It looks like it flattens out, but that's just because this is so pixelated, but it looks like that. So our domain is going from there to there, so all of our stuff less than 4, but all of our stuff greater than -4. So anything in there. So I can say -4 to +4, or we could write it like this. Oops. Would be another way. Then the range, again, is going to start at the lowest. What's the lowest value you can have? And if we were to plug a 4 in there, this would be 16. 16 minus 16 is 0. So 0 is definitely where we can start. And then it's going to go all the way up to 4. That was the highest point of our graph. We didn't have any parts that arrowed up forever, so it's just going to stop up there at 4. Or you could write it in interval notation. So lots of calculator work today. Graphing the pictures, make sure that you both graph and kind of think about them conceptually. Like, do I have asymptotes? Am I parabola, so I'm going to go up or down forever? If I have a root, I got to think about what values only make it positive, because we can't root negatives. So it's just kind of that slow, methodical look at functions and then deciding their domain and range.